Greetings, my name is Mark Fries, and my co-authors and I are presenting this poster on a recent, unusually close encounter between Mars and the orbit of comet C2007 H2 Skiff. Previously, we have hypothesized that orbital interactions such as this may generate significant amounts of methane in the Martian atmosphere, and this interaction presents a superb chance to test that hypothesis. A well-known paper by Mumma et al. Reported that in 2003 there was the sudden appearance of a significant methane plume in the Martian atmosphere. And shortly thereafter, a paper by Misha et al. Reported, on the basis of atmospheric modeling, that this plume must have appeared only a few sols before the observation was made. Unknown to either of these authors, only a few sols earlier, Mars had encountered the orbit of comet H2 Skiff at a very close interaction distance of only about 1/3 the Earth-Moon distance. This should have generated a meteor shower on Mars and deposited a fairly significant amount of carbon-rich material into the Martian atmosphere. The interactions between Skiff and Mars have been modeled by Christo and Vabion, who not only identified Skiff as a potential source of significant meteor showers on Mars, but also showed that the distribution of debris is capable of producing outbursts of meteor activity. And this isn't the first time that Skiff has been implicated in meteor activity on Mars. In 1997, on the same day as the closest approach between Skiff and Mars, a high-altitude dust cloud was seen to appear at Mars's terminator, possibly from infall from the comet. We have hypothesized that interactions such as this with Skiff and other comets may be a significant source of methane in the Martian atmosphere, especially transient events such as the plumes noted by Mumma et al. And we invite you to go read our 2016 paper for more information. Now, orbital dynamics being what they are, Mars and Skiff can be counted on for additional interactions as the years go on. And it just so happens a very significant interaction occurred on the 24th of January of this year. To illustrate how close the interaction between Mars and Skiff is, this graph shows all the major meteor shower generating interactions between Earth and various cometary orbits. And you see that you get significant meteor showers all the way out to nearly 175 times 10 to the minus third AU, or many times the Earth to Moon distance. By contrast, the interaction between Mars and Skiff for the Mumma et al. Methane plume occurred at only 0.8 times 10 to the minus third AU, or about 1/3 of the Earth-Moon distance. The 24 January 2018 encounter occurred at only 0.21 times 10 to the minus third AU, or only 0.08 lunar distances. In order to test the hypothesis that cometary encounters can generate methane, it's not enough to simply say that the orbital interaction occurred. We need direct evidence that a meteor shower, and a significant meteor shower, actually happened. The MAVEN spacecraft is capable of doing this. While it cannot detect methane directly, it can detect magnesium in the upper atmosphere of Mars, deposited there by meteor showers. MAVEN can test for evidence of an actual meteor shower, and to complete the test of the hypothesis, we need a measurement of whether methane actually evolved during the encounter. We're aware that at least one terrestrial observatory was watching Mars for exactly this measurement at the time of the encounter, and we eagerly look forward to the results of both MAVEN and the terrestrial observatory information. The 24 January encounter, we believe, is an excellent test of the hypothesis of whether cometary debris can generate methane at a significant quantity in Mars's atmosphere. This is important. For one thing, it gives us a new understanding of the chemistry and dynamics of the Martian atmosphere. For another, it is imperative to have a full accounting of the abiogenic sources of methane on Mars before we can say with any certainty whether there is a biogenic signal present, whether or not methane constitutes a sign of life on that planet. Thank you very much for your time.